Alrighty, hopefully we're back on YouTube for you guys on Facebook. Sorry, technical issues and stuff happens. You know, it's modern technology, unfortunately. I'm just gonna go check the other machine real fast. Be back. All right. Hopefully we can try and get everybody back. Okay, I can hear myself over there somewhere, so it means it's back. Oh, we got some more people on Facebook. Hello. Actually, no, it's the internet here in the store. Believe it or not, I'm actually at work here. We usually set up these videos, but we've been basically trying something different in terms of doing some of the videos. Is we're not doing all prefabricated videos. We're doing some live ones so we can get to talk to you guys and get your feedback and things like that. So that's essentially what we're doing. So I lost my train of thought from what I was originally talking about, so you guys might have to remind me. But yes, do we have questions? I'm sure you guys have questions. I know some of you said that you guys are just listening and learning. There's only so much I can yak on for. Usually it's easier when I answer questions. What was the question that you had earlier on? Oh, that's right, you said you were more visual than anything else. What more can I say visually? You know, the interesting thing here is it really is a case of what you're more interested in when you're using or doing solar in general. From a visual standpoint, that is, a lot of people have an expectation of what they're going to see. They look at the sun and go, okay, I want to see sunspots and I want to see the stuff, you know, jumping around and, you know, flares in real time and all that kind of crazy stuff. Well, just to give you a heads up, that doesn't really happen that way. What tends to happen here is when you see these prominences and these loops that arc up and come straight back down again, that stuff from our perspective, because we're so far away, we don't actually see any of the integral movements. So for all intents and purposes, it looks like it's just standing still. It does change every minute, believe it or not. You know, I always hear the argument saying, oh, it doesn't do anything. You can stare at that thing for like, you know, 20 minutes and nothing happens. But I've actually had footage that is 30 seconds apart, and I will shoot an entire series of this. And it's quite amazing how fast everything changes. And you can even just watch the spicules. Spicules are normally like little things that just leap off. They look like grass on the edge of the sun, but spicules can also be seen on the supposed surface, even if it's facing us. Now, if you were to do a time lapse of these spicules, for example, you can actually see that almost every frame they will move. Now, let's just say we can get in a spaceship and fly towards the sun and not get incinerated. You can actually see the closer you get, the more apparent movement you actually come across. So when you're watching one of these big ass arcs that come up and then down, you can actually make out watching the plasmid come up and come back down again. It's no different from watching a fire. From far, far away, the fire is just a point source of light. And, you know, every now and then it flickers and, you know, you might be able to say, oh, there's a fire over there. But the closer you get to this fire, the more intricate you start to see. And then you realize, oh, you know, this thing is really going for it and burning everything down. The same principle is the same with the sun, even though the sun technically isn't on fire, because, you know, you have to have air at the end of the day in order for something to burn. There's got to be oxygen. And yeah, you've got the fuel source and everything else and the ignition source, but you don't have air, unfortunately. So as you get closer to the whole thing, you really do see the plasma, bobbling around. It's quite spectacular. It's a shame that it can't happen, but the closest way you can do it is you can get a really big telescope. Can be a bit boring though. Oh, what? We got a question. I use the Coronado at Neve, very cool. Only time I use the SolarScope, use the Barter White Light Mylar, have been for years. If you want to cut corners because cost is an issue, and you like doing white light, I actually would recommend you trying out a solar wedge. A whole bunch of people make solar wedges. They're very easy to find. They're not expensive by any shape of the imagination. I do recommend that you have a UV-IR cut and the Barda solar continuum filter when doing white light. Why? It basically enhances the contrast to look at that surface detail, that crackling of glass, which is really, it's actually quite interesting. If you do a search on the internet for SDO, Solar Dynamics Observatory, they actually show all the different types of band passes. The one for white light you need to look for is, I think it's just HMI or something like that. It's closer to the bottom. It's black and white. And if you actually click on it and load the big full version, the 4000 by 96 pixel resolution image, you can see that crackling surface. That is not exaggerated NASA data. This is straight up, that is what you really see. You really can see that crackling, especially under high magnification. So from a visual standpoint, ideally, the best way to see that level of detail is you need a scope that's at least 150 millimeters. You're going to be using a very high powered eyepiece, so to speak. I would probably put it in the region of, say, a 12 millimeter at the low end of the scale, and maybe go as high up as, say, I'd say a 6 or a 7, depending on seeing conditions. If you've got 5 out of 5 seeing and good transparency, which I'm going to go into that in a second, you're in for some crazy things, especially when there is something going on. Because when you see active regions in the photosphere, a lot of people think that you can't see this stuff. It's only in the chromosphere. You can see the photosphere when there is an active region. It looks like something else is happening. Like I said, it looks like a lightning bolt went across it, and wherever the lightning traced across, you just throw sand at it, and where the sand sticks to, that's kind of what it looks like. It's really odd to explain. You just got to see it, for lack of a better description. The poles of the sun, usually the North Pole tends to have the most amount of this kind of weird crackling on there. It's kind of tricky to see. But then when there is an active region rolling around, you can see all of these things. Just so you guys are knowing, as of today, we have a very small sunspot on the eastern limb. In other words, it's rolling away from us. It's still visible right now, so if you've got clear skies and you've got a solar filter and all that kind of good stuff, by all means check it out. On the other side coming towards us, which is the western limb coming around, the active region from about 2-3 weeks ago is actually coming back round, so you'll be able to observe some of the more intricate details. I don't think there's going to be a sunspot there. It doesn't look like it's growing. You can actually get all of this data from, like I said, you can actually get all of that information from the Solar Dynamics Observatory website. It's all down through NASA. It's actually free. I like to check out daystarfilters.com all the time. They have live views all around the world of the sun. Anywhere from here, as in California, to Spain. They have one in India. They have one in Australia. Oh, geez, they name it. Hawaii. It's a great resource for looking at what's going on. But Solar Dynamics Observatory, SDO from NASA, if you look at stereo, unfortunately, stereo B doesn't work. They lost contact with that probe ages ago. Stereo A is what it's called as. So it's A and B. A's ahead, B was behind. But A shows you what's coming. So ideally, when you see stereo A, it's greenish in color. So just so you know what you're looking for, you will actually see if something is actually coming round. So the idea here is you want to see it at the 45-degree marker. That's when you know it's pretty much in view. When it's away from it, going more towards a 90, it's very, very tricky to work out if anything good is coming around. However, if you see a good active region and you kind of make out some of the flare action going on, you'll know prominences are also coming around at the same time. Depending on what the magnitude of all of that stuff is, not that it's a good thing. If you get a Class X solar flare, they create some of the best arcs out there. Now, currently the sun is in solar minimum and we are coming out. This has actually been one of the longest solar minimum cycles we've had in a long, long time, compared to solar maximum cycle that we had, which was just phenomenal. I mean, we saw some of the most amazing flares and prominences, and you name it, we saw it. I think the best highlight that we saw in 2017 was the double magnetic loop. You can see magnetic loops all the time, so to speak, if the sun was active, but you don't see double magnetic loops. In other words, it's a loop and another loop inside of it. There are plenty of pictures on the internet of the double magnetic loop. It was quite something to observe. You could see it visually, you could do it via imaging. Again, you could only observe that through hydrogen alpha, one of these guys. I mean, if you had this, it'd have been great. It's just night and day difference, to do that. Roy, do you need to collimate these guys? No, there is nothing to collimate. It's not actually collimatable. So again, do not open these things up. Do not mess with them. If you feel you have a problem, Daystar filters customer support is like second to none. I mean, they will bend over backwards for you to make sure everything's working. So if you were to buy something like this and you had a problem, they will do their best to remedy every aspect. So again, there is no collimation required on these scopes, and again, do not mess with the collimation, especially do not remove this area. It's not because there's like sensitive pieces and so forth. It's when you crack these guys open, once you introduce dust into all of these systems, it's almost impossible to take out, and you sure as heck don't want to be fingering that blocking filter, because you can leave a fingerprint on it very easily and it's virtually impossible to remove. So again, do not touch it or mess with it too much. If you do feel that it's due for a cleaning, contact Daystar Filters, give them a shout, and they will basically take it from there. At the end of the day, let the experts do all the work. As far as I'm concerned, why do it yourself when you can have them do it? If they charge you, it depends if it's in warranty or out of warranty, not specifically. So again, it just depends on the situation. They do have high-end filters. If you're in that type of mood, they are known as the Quantum line. I've yet to have a go at a Quantum. I have been dying to use a Quantum for I don't know how long. I haven't even found anybody who owns a Quantum that is willing to let me touch their Quantum, let alone breathe all over it. What's the difference between the Quantum and the Quark? Well, the Quantum is generally made for research grade purposes. The accuracy tends to be a lot higher. They guarantee the performance. So if you buy a 0.3, you get a 0.3. They work in the same principle. You're still heating up the crystal that's inside of them. The band shift is still exactly the same. There's a couple of minor differences. It's not, manual knob twiddly bit. It's actually done, with a serial to USB plug, and you can control the entire system. And geez, the only way to describe it is when you're doing 0.3 angstrom from an imaging standpoint, it's like all the details are like razor thin. It's like super sharp. It's just scary almost what you can see. Again, I haven't personally seen one, and I've been dying to do that, and no, they won't lend me one because, they're only like about $50,000 each. Just to give you an idea of the usage behind them, it's not a consumer grade product. It is a very high-end product. NASA has used them before. I believe there was a SpaceX launch the other day, and one of the telescopes that they sent up was for the US Air Force. And one of the functionalities of this telescope that they sent, and it's an optical telescope, by the way, that they sent up. Actually, the guys from Daystar Filters were involved in the development for the hydrogen alpha portion of that, from what I can remember. So again, these guys aren't, fly-by-night cowboys. They've been around for a very, very long time. They probably, like I said, make some of the best solar filters out there. So before we wrap this up, I've still got a couple of people here. If you've got any questions, now's your chance, because we're going to be closing pretty soon. And I do apologize for the hiccup that we had earlier. If you guys have just joined us, you can watch the replay, of course. There's part 1. I'm going to have to rename all of this stuff and change all the things and bits and pieces, but you can kind of catch up on what you've missed or what you haven't missed. So again, this is the SolarScout from it's upside down, from Daystar Instruments. Hopefully this is the right way around for you guys on Facebook, and for you guys on YouTube. That's what it is. And this is the Quark combo, and there's people walking into the store. There it is there. Again, they have different versions. Make sure if you're buying any of the Quarks that it's the one for your particular scope. I do not recommend using these on Newtonian telescopes. It's not what they're designed for. They're more for SETs. Again, you have to have some kind of ERF, especially if you're using the combo. Read the instructions, check out their website. Remember, safety is of absolute paramount, so don't kill yourselves over this thing. So yeah, the regular version is literally just called the Quark chromosphere. There's no other name for it. The other one is known as the combo. This is the combo. If you have a refractor, you need the regular version. If you're doing SAT, combo. It's the only way to remember it. This is basically the same as the regular Quark. It already has a telecentric Barlow. That's why it can get to 930 millimeter focal length, because let's face it, 60 millimeters can't do whatever. It's 60 millimeters is what f something, f4, f3, f5 is going to give you around about a 240 millimeter focal length. So how's this jiggery pokery happening? Oh, of course they're using a telecentric Barlow of some description. So that's it. This is the Daystar SolarScout. You can check out more information either on daystarfilters.com. If you're interested in buying one of these bad boys, I've got plenty of these in stock. Just check out our website, telescopes.net. That's telescopes.net. Or you can give me a call at 888-427-8766. And we should be good to go. And hopefully, I look forward to speaking to you guys and sell some of these bad boys, because they all need homes to go to. And good night. God bless. Thank you very much for watching.